A logarithm basically is the inverse of an exponent. And what they're mostly used for are actually what we've been doing the last couple of days, which is solving exponential equations that when they don't have a common base. So the ones you were doing before solving exponential equations was when they had a common base and you could change everything, say, to a base 2 and then figure out what the exponents are. But if you can't do that, then logarithms are the way that that would be solved. So that's what we're going to work towards. But first we're just going to look at what a logarithm is, how it's set up, and evaluate a few of them. There are also things in nature that follow a logarithmic growth, but more often we use them for things that are growing exponentially. But we're going to look at just evaluating some logarithms today. Then we're going to look at logarithmic functions, laws of logarithms, solving logarithmic equations, and then applications, mostly of exponential functions, but using logarithms for that. Label the components of this logarithm. And the exponent. So let's do the exponent first because you probably know some of those parts already. So some things we know. Like the base of the logarithm. What's the e? The exponent. We know that. And we're going to call a the result. So the thing that it equals, we're going to call that the result. So on the other side, what would you call the result of the logarithm? That's the e. No, we're going to call it result. The a is called the argument. Yeah, and then the b is the base. And the way that they're related is this. One can switch into the other, and there's like a little rule for switching them. If you have something that's a logarithm and you want to switch it into an exponent, well, this that it shows here is how they're related. The base of the logarithm becomes the base of the exponent. The argument of the logarithm becomes the result of the exponent. And then the result of the logarithm becomes the exponent. So this actually shows you here how they're related. If I take, so for example, let's do log base 3 of 9 equals 2. And I want to switch that into exponential form. Base stays base. So when you switch to exponent, the base is still the base, but the other two switch. So the number that was with the 3 before goes to the other side. The number that was on the other side comes over as the exponent. So the log base 3 of 9 is equal to 2. 3 to the power of 2 is equal to 9. Those are actually both saying the same thing in a different way. That's what we're going to do here. Evaluate these logarithms. So I'm going to show you how to do it algebraically. I'll also show you a little trick for using your calculator too. But when I want to evaluate a logarithm, I make it equal to x or some variable. Switch it into exponential form, and then I'm able to solve. So this one switches to 2 to the power of x equals 1. And this is what we've been working on, solving equations like that, right? So I need them to write that as a base 2. 2 to the power of x equals 2 to the power of 0. 1 is 2 to the power of 0, so x is equal to 0. So log base 2 of 1 is equal to 0. Why don't you guys try the other two? Or at least the next one. We'll talk about the third one. So that one is equal to 2. This one just says log 10. What's the base on that one? It's 10. Log base 10 of 10. Yep. It's just like when you see a square root and it doesn't have an index, we assume it's 2. With a logarithm, we assume the base is 10. And if you see the log button on your calculator, that does base 10 logs. So if you just press log 10, it'll give you the answer to this one. It'll give you the answer when the base is 10. And who knows what it is? 1. You have a few others there on your sheet than what I have here, and I'll give you some time to do those, but we're going to keep moving forward, and you can come back to it after. This one is just asking, express each equation in exponential form. Log base 2 of y is equal to x. So just using that rule of base times base, and the other two switching, this becomes 2 to the power of x equals y. So we just switched them. The x and y, and the base stayed the same. This is on the second page, I think. No, third page. Yeah, on the third page. Now the second one here, in order to switch it into exponential form, we have to isolate the log first. So what can we do with that a? Not subtract it, because it's multiplied, right? Not added. So we can divide by a on both sides. And we'll get log y is equal to x over a. And remember, it's log base 10. So when I switch it, it becomes 10 to the power of x over a is equal to y. And the last thing I have for you is the opposite of that. It's given in exponential form. We want to write it as a logarithm. So y equals x squared is going to switch into log base. What will the base be? Log base x of y is equal to 2. And then this last one, log base 10, which I don't need to write a base 10. You can if you want. But of a is equal to y minus x.